Hi, and welcome to this video on control flow and algorithms. I'm Andrew. So far, the programs that we've been building have been using sequence and data, allowing us to work with methods, having sequences of method calls with variables to store data that we can assign values to and that we can use. This has meant that our programs are very limited. They always perform the same actions every time they are run. In order to make our programs more interactive and responsive, we need to start understanding how to use what are called control flow statements. And that's the focus of this chapter. When we have control flow statements, we'll be able to get our programs to respond dynamically to inputs, to things from the world around them. And this will make them much more interesting and much more capable. In this chapter, we're going to look at building algorithms and how control flow statements are the foundation of those algorithms. We'll look at Boolean logic, the idea of instruction flow and how that works, selection and branching within control flow, as well as loops and repetition. Let's get started with that. Boolean logic is the core of all of these control flow statements. So as you're exploring this chapter, Boolean logic will be the first thing you need to look at. Boolean logic lets you add a condition where you check whether something is true. We could say something like, is today Friday and is it after midday? We could say something like, has the user clicked this button or have they typed this character on the keyboard? These are the kinds of things we can capture in Boolean logic, which then allow us to make a decision in our code as to which instruction is going to occur next. Control flow is an interesting term. Why is it called control flow? This all comes back to the idea of picturing your computer as having a stream of instructions that are flowing through the computer. So the CPU is running these instructions one at a time in sequence, and they flow through the computer. So one instruction executes, then we flow on to the next one and the next one. And we can introduce branches, points where we go in one way or another, and we can introduce loops through control flow. In this context, branches can be achieved by having a condition, which then allows you to choose between a number of different paths to take. So the compiler can inject an instruction that says, if this condition is true, jump to this instruction and execute that branch. And when we get to the end of that branch, it jumps to the end of that group. So the idea is each of these has a single point of entry. So we get into this branching instruction. It will then take one of these branches. And when it finishes, all of the different branches here, notice they all come back together and continue on the flow into the next part of the program. So we create the branches in a structured way. We take one of the branches, join back in, and we flow on to the next lot of instructions after that. It's the same with loops. So the idea of loops, we have a single entry here, and we have a single exit. So we go into the looping instruction. There's the loop, which has its instructions inside it. And when that loop finishes, it goes on to the next instructions. Inside programming, we've got generally two different kinds of loops. Either we can have the condition first, which would be called a pre-test loop. So when we go in, the first thing we do is we check the condition. If the condition is true, we go through the loop and we end up back at the condition. If the condition is still true, we go through the loop again, we get back to the condition. When that condition is false, we then exit out. With a pre-test loop, if the condition is before the instructions, then that means the loop can run 0 or more times. If it's false the first time, we come in, it's false, we don't go in and we don't execute the loop at all. The other place we can put the condition is after the instructions. So that would mean we come in, we run the instructions that are inside the loop first, we get to the condition, and if the condition is true and we want to repeat the instructions, then we go back, we repeat those instructions, and then we get back to the condition again, repeat the instructions back to the condition, and then eventually exit. With a post-test loop, you have to execute the instructions at least once, but you still have that idea of repeating the instructions. So are you ready to master control flow? Dynamic behavior requires the ability for you to control the sequence of instructions that are running through the computer. You need to be able to inject decisions that say whether they should go one way or another way. As you're exploring through this chapter, make sure to pay attention to Boolean logic. This will let you craft those conditions, determine exactly what goes inside them. You need to picture instructions flowing through the computer. And control flow is you controlling where that flow goes. What is the next instruction? That's what you're determining here. Control flow is all about saying, I want the next instruction to be this instruction instead of being the one that follows in memory. We can do that in one of two ways. We can do that with branching, where we make a decision and we say either go this way or go that way. Run this branch or that branch, come back together, and then keep going again. Or we can use loops and repetition, where we have some instructions that we repeat. So a decision to jump back and repeat the instructions. Jump back, repeat, 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 and then end. Remember, with both repetition and with branching, you are using the Boolean logic, so the Boolean expressions, to control which of those instructions is chosen at the point in time when that condition is checked. Learning about control flow is a big step. So spend the time, make sure, don't take any shortcuts with this, try to go through it carefully and practice make some little programs to test out each of the different control flow ideas and think about how you can combine them together to achieve different things. Once you get this, the next lot of tasks are going to the next lot of chapters are going to give you some tools to help make your programs bigger and easier to work with as they get larger. But at the heart of all of those programs is control flow. So a really solid understanding of control flow will mean that you will zoom through the rest of this material and really understanding it. Okay, enjoy the journey.